Hey everyone, it's Professor Pemberton. In this video we're going to look at combinations of functions including operations on functions. So we're going to start off this section by looking at how do you find the domain of a function, and then we're going to look at how do you combine functions using algebra, such as addition, subtraction, multiplication, and division, with functions, and then also specify their domain. We'll look at composite functions in the next video. So in this section we're going to look at forming a new function using a combination of two older functions, two given functions. And more importantly, we're going to be able to determine the domain of a function, the new function, by not knowing what the graph looks like. We'll be able to find the domain by just knowing what the function's formula is. So let's start off with domain. So let's look at the domain of a function. Functions that model a physical situation, they usually have their domain explicitly stated. So think about the problem that we did earlier in this chapter involving the cell phone plan. Well, the cell phone plan only made sense for certain values of how many minutes you're using in a month. Well, that's the domain of the function. It might be stated explicitly or given in the equation of the function. However, more often is the case, you will not have the domain stated for a function's formula or an equation. So most functions, they're just given with a formula, and the domain is not stated. So if there are cases like this, you always have to keep in mind the domain of a function is the largest set of real numbers. So that could be the set of all real numbers, except you need to make sure that the value of f of x is a real number. So in other words, the y value is a real number when you substitute in the x value. When you're finding the domain of a function, you need to exclude all the x values in the domain that gives you a y value that is not a real number. So here are a couple situations where that might come up. So there are two operations in mathematics that can give you an undefined real number. So number one, you're not allowed to divide by zero in mathematics. So number one is, if you are plugging in an x value into your equation or your formula and it results in division by zero, then that x value is not in the domain because it would violate the definition of a function. The definition said every x value must have exactly one y value. So if you can't find a y value, then that x value is not in the domain. So let's look at an example of number one. So f of x is equal to 1 divided by 3x plus 2. So let's see. What would make the denominator 0? Well, let's take the denominator. We can plug in any x value that we want, but we want to make sure that the denominator is not 0. So take the denominator, make sure it's set not equal to 0, and now you can solve for x. And when you solve for x, you'll come up with x is equal to negative 2/3. X cannot equal negative 2/3 after you subtract 2 and divide by 3. So what does this tell us? Well, that means if I tried plugging in negative 2/3 into this function, I will not get a y value. So let's try it out. You'll have 1 divided by 3 times x, which is negative 2/3, and then you want to add 2. Well, the denominator becomes 3 times negative 2/3, that's negative 2. So we'll have 1 divided by negative 2 plus 2, which gives you 1 divided by 0. And of course, that does not exist. It's undefined. In other words, it's not a real number. So here's one x value that does not have exactly one y value. It has 0 y values. So that means negative 2/3 is not in the domain. But all the other x values are fine. If you plug in any other x value into this function, you will find exactly one y value. So let's write out the domain using interval notation. As we've seen before, domain would be the set of all real numbers except negative 2/3. So any value that's less than negative 2/3 is okay. make sure there's a parenthesis on negative 2/3. You do not want to include negative 2/3. So it's a parenthesis. Union, because now you want to talk about all the values of x that can be greater than negative 2/3, because those are also in the domain. So negative 2/3 to infinity, and also a parenthesis on the negative 2/3. So there's one operation where you have to concern yourself with finding the domain. The other operation in mathematics is real numbers that result from an even root of a negative number. In other words, you cannot take the even root, the square root, the fourth root, the sixth root, the eighth root of a negative number. Those don't exist. So let's call this function g of x. G of x will be the square root of x only. So this is, even though there's not a number on the root, it's called a square root. So it's assumed to be a 2 there. So this is an even root because it's a square root. Which means that I can only have positive values inside the root or 0. It cannot be negative. So that means x must be greater than or equal to 0. So don't set it equal to 0 or not equal to 0. What's inside the root is positive or equal to 0. That's what that means. And now if you write this as a domain with interval notation, the domain would be, I want to include 0 because it's or equal to, so square bracket, 0, comma, and it's all the x values larger than 0, so it goes up to infinity, parentheses. So let's try out an x value that would not give us a real number as a y value. So if I plug in any negative number, so let's try negative 4. If I plug in negative 4 into this function, I would get the square root of negative 4. And this means what number times itself would give you negative 4? There isn't one. So this is an undefined real number. It does not exist. And so there's a negative number. If I plug it in, I do not get a y value back. So any negative number would not work as part of the domain. Okay, so the definition for finding a function's domain. If a function f does not model data or a verbal description, the domain is assumed to be the largest set of real numbers where the y value, f of x, is a real number. So in other words, you assume it's the set of all real numbers except for values will make division by 0 or an even root of a negative number. And then you have to exclude from the function's domain real numbers that cause division by 0 or real numbers that result in an even root of a negative number. So those are the only two cases to be concerned about for now. Okay, so example 1, we're going to find the domain of the following functions and of course write the answer in using interval notation for the domain. So number 1, let's try out finding the domain for f of x equals negative 3 divided by 2x plus 5. So we did something similar just a minute ago. If we have a fraction and there's variables in the denominator, that could cause problems with the domain. So I need to take the denominator, 2x plus 5. It cannot be 0, because if it is 0, then that's going to cause a problem with the domain. So if I solve for x, I get x cannot be negative 5 divided by 2. And so now we can write the domain. The domain would be the set of all real numbers except for negative 5 divided by 2. So any real number less than negative 5 over 2, union any real number greater than negative 5 divided by 2. So negative 5 halves with a parenthesis, comma, infinity. And so this type of function we haven't talked about yet, but it's called a rational function because it's a function of x's in the denominator. Now, one thing I like to do is that how can you find out the domain? How can you write the domain so easily when you just know that x can't be negative 5 halves? Well, and since I'm a visual learner, I usually like to think about this as a number line. This number line represents all x values that's making up the domain. The only value on this number line that I cannot plug in, let's put it right in the middle, which is negative 5 halves. Now I want to exclude it. So remember, an open dot means exclude. So that means the rest of the number line is okay. So I would shade the rest of the number line. Anything less than negative 5 halves and any x value greater than negative 5 halves is okay in the domain. So now let's write out each of these intervals. This would go to the left forever, so negative infinity, up to negative 5 halves. Open dot means parentheses. Union, because now there's another interval. The other interval would be negative 5 halves, because that's where it would start on the left and would go up to the right forever. So infinity, parentheses. And notice that's exactly what the domain that we had written before. Okay, let's try a different rational function this time. Number 2. The function is g of x equals 6 divided by negative 3x plus 4. And so this is another example of a rational function. Because you have x's in the denominator again. So just like the last problem, notice the numerator had nothing to do with the domain. We're only concerned about division by 0 if there's a fraction with x's in the denominator. So your negative 3x plus 4 cannot equal 0. If it is 0, then that x value is not in the domain. So now let's solve. Subtract 4 on both sides first to get negative 3x cannot equal negative 4, and now divide both sides by negative 3. So x looks like it cannot be equal to 4/3. So let's write out the domain using interval notation. It's the set of all real numbers except for 4/3. So negative infinity to 4/3, union 4/3 to infinity. Any value less than 4/3 is fine. Any value greater than 4/3 is okay, but just not 4/3. And of course, the number line will look very similar to the last example. Your number line would be all x values except for 4/3, which would have an open dot, and the rest of the number line would be shaded. So shade to the left forever, and shade to the right forever, but not 4/3. So that would be negative infinity to 4/3, union 4/3 to infinity. Okay, so hopefully these first two examples gives you an idea of how to find the domain for a rational function. Now let's do two more. This time we're going to look at a radical function. So 3, let's look at h of x, which is equal to the square root of 7 subtract x. And so this is called a radical function because it has a radical where x's are inside of the radical. So keep in mind what we talked about earlier. If it's an even root, so like a square root like this function, what's inside the square root must be non-negative, which means it must be greater than 0 or equal to 0. So 7 minus x greater than or equal to 0. That's the inequality that you have to set up. So don't set it equal to 0. That doesn't tell you anything. You need to make sure you have it greater than 0 or equal to 0. Now solve. So to solve this inequality, make sure you isolate the x on one side again. So let's subtract 7 on both sides to get negative x is greater than or equal to negative 7. And now remember, if you ever multiply or divide by a negative number when you're solving with an inequality, you have to reverse or flip the inequality symbol. So let's divide both sides by negative 1. And now it was greater than, now it flips to becomes less than or equal to. Negative 7 divided by negative 1 becomes positive 7. So this means any x value that's less than or equal to 7 is in the domain. So let's write this out with an interval notation. The domain would be any x value less than 7. So negative infinity, comma, 7. And notice that this one has or equal to, so you do want to include 7. So square bracket. So let's make a note when we solve this inequality. Reverse the inequality sign. when you multiply or divide by a negative number. So again, it does help to see what this domain looked like if it was graphed on a number line. So let's graph really quickly. So this number line represents all possible x values in the domain. The only value that we're concerned about is number 7. And now we want to figure out which part of the number line do we shade. Well, you want to include 7 and any x value less than 7. So I want to shade to the left forever. And I do want to include 7, so you can either use a filled in dot, a closed dot, or you can also use a square bracket to say that you want to include 7. So this interval would be -infinity to 7 with a square bracket, just like we had before. Okay, let's try one more radical function, number 4. This time the function is k of x equals the cube root of 3x plus 7. And so another radical function. So notice this time that it's not just any type of radical that we're concerned about with the domain. It has to be an even root that we're concerned about, because we can't take even roots of negative numbers. Well, this is an odd root because it's the cube root. So the domain is the set of all real numbers. There are no x values that you have to exclude because you'll never have a negative inside an even root in this problem or in this function. So the domain is the set of all real numbers. So -infinity to infinity. Which means that any x value can be substituted into the function k of x and obtain a y value. So I can plug in positive values for x, I will find a y value. If I plug in negative values, I will find a y value, and if I plug in x equals 0, I'll still have a y value every single time. So in other words, there are no values to exclude. I will find a y value for every single x. Okay, so the last part of this video is going to talk about how do you make a new function by using an algebraic operation with functions. It turns out that with addition, subtraction, multiplication, and division, you can do those with real numbers, but you can also do them with functions. So you can add functions, you can subtract functions, you can multiply functions, and you can divide functions. So here's a definition on operations on functions. The two functions are called f and g, and here are the names of the new functions. The sum function, the name is f plus g, and how do you find it? You take the two functions and you add them together. So combine like terms. And how do you find the domain? Well, the domain of this new function is the intersection, or what x values are in common with the domain of f and the domain of g. The difference works the same, just have to be a little bit careful with the difference because the order matters when you're subtracting. Difference is f subtract g, so the name is f subtract g, and how do you find it? You take f of x first, because that appears first in the difference, then subtract g, because it comes second. And the domain is found the same way. The domain of f subtract g is the x values that are in common with the domain of f and the domain of g. The product function is f times g, so notice that there's no operation between f and g, so it's assumed to be multiplication. F times g of x, you take the two functions and you multiply them together, so f of x times g of x. And the domain is the same. It's the x values that's in common with both f and g. Now you have to be a little bit careful with quotient, because a quotient, you are forming a fraction. You are forming a rational function. So f divided by g And keep in mind, the order matters here too. F is in the numerator, g is in the denominator, so it's f of x divided by g of x. And keep in mind, your denominator cannot be 0, so the domain of f divided by g is the intersection of all the x values in common with f and g, except the x values that make the denominator 0. So let's see what all this means with example 2. You're given two functions, f of x and g of x. F of x is x minus 5, and g of x is x squared minus 1. We're going to find the following operations and also the domain. So number 1, let's start off with the sum function. So f plus g of x. So this is the new function. You find it by adding f of x and g of x. So x subtract 5, you're plugging something in for f of x, make sure it goes in parentheses. And you're plugging in for g of x, so x squared minus 1 goes in parentheses. And now notice, you need to add like terms to simplify completely. So you have x squared, no other x squares. You have an x, no other x's. And now you have negative 5 plus negative 1, it's negative 6. And so this is the new function. It is x squared plus x minus 6. Now let's find the domain. The domain would be all the x values in common with f of x and g of x. Well, f of x, I'm not dividing by 0, ever, and I'm not taking an even root, because even roots don't even show up in the function. So the domain of f is all real numbers. G of x, the domain is all real numbers because I'm not dividing by 0, there are no x's in the denominator, and there are no even roots. There's an even power, but it's not an even root. So the domain is negative infinity to infinity, which is the set of all real numbers. So number 2, let's find out what is the difference function. But this time we're going to do the difference g subtract f of x. So keep in mind, the order is important. G subtract f, that means g of x subtract f of x, in that order. So be very careful when you are subtracting functions, because you want to subtract the entire function f of x. So g of x, x squared minus 1 in parentheses, then subtract the entire f of x. So subtract x, subtract 5. So we've seen this before. If there's a subtraction sign before parentheses, that negative sign has to be distributed to both terms, which will change the signs. So the first parentheses will stay the same, x squared minus 1. You'll have minus x and plus 5. And now combine like terms. So there's an x squared, a minus x, and negative 1 plus 5 is 4. So let's find out the domain. The domain would also be the set of all real numbers for the exact same reason as we've seen before. F of x has a domain all real numbers, g of x is the set of all real numbers for the domain, and g minus f is the intersection, or what's in common? Well, everything's in common. So negative infinity to infinity, all real numbers. So there's two functions. Let's talk about 3 different operations now. Okay, number 3. Let's find out the product function, f times g of x. To find it, you take f of x and you multiply g of x. So f of x was x subtract 5, g of x was x squared subtract 1, and we want to multiply these two functions together, and notice that you have to multiply using FOIL. You have 4 multiplications to do. So first, outside, inside, and last. So first would be x times x squared, x cubed. Outside would be x times negative 1. Inside would be negative 5 times x squared, so negative 5x squared. And last would be negative 5 times negative 1, which is positive 5. And so it's very common to rewrite this with the highest power first, the next highest powers next, and so on. It's what's called descending order. So x cubed first, subtract 5x squared, subtract x, and then there's a 5. There are no like terms this time. Domain. Well, the domain's a set of all real numbers exactly for the same reason as the last two are the same as a set of all real numbers. Okay, two more. Number 4, we're going to find out the quotient function next. This time we're going to do g divided by f. So like I said before, the order is important. G is in the numerator, f is in the denominator. So it's g of x divided by f of x. So g of x was x squared subtract 1. F of x is x subtract 5. And this is simplified completely. You are only allowed to simplify if you have common factors in the numerator and denominator. So let's try factoring the numerator. X squared minus 1, that will factor as x plus 1 times x minus 1. So that was because we wanted to factor the numerator. And the way to factor x squared minus 1 as x plus 1, x minus 1, this is because it's a difference of squares. So notice the first term is x all squared, and the second term is 1 squared. So it's x plus 1, x minus 1. One parenthesis gets a plus, one parenthesis gets a minus. And the pattern is this for difference of squares. A squared minus b squared will factor as a plus b times a minus b, always. So that's the numerator. And the denominator is x subtract 5. Well, notice that there are no common factors, so nothing cancels. So now we're ready to find out the domain. So it's not going to be the set of all real numbers this time because we are forming a fraction. So we're going to have to find out what x values make the denominator 0. It looks like 5 because x minus 5 cannot be 0. This is a rational function now, so that means x cannot be 5. Because if x was 5, that would be division by 0. So it looks like negative infinity to 5, union 5 to infinity. So x value is less than 5, x value is larger than 5, but not 5. Okay, let's try one more out, number 5. So let's try f divided by g this time of x. So this is another quotient function. So f of x is in the numerator this time, and g of x is in the denominator. So yes, it's going to be the reciprocal of the last problem. It'll be x minus 5 divided by x squared minus 1, and we know the denominator will factor as x plus 1, x minus 1. And that's simplified completely. And the reason why is because you want to factor the denominator this time. Using a difference of squares. A squared minus b squared is a plus b, a minus b. So same as before. And notice that no factors cancel, so this is completely simplified. So now we're ready to find out what is the domain of this function that we've just found. Keep in mind that the numerator is not important when you're finding out the domain. So the denominator cannot be 0. That means x squared minus 1 cannot be 0. Or that means x plus 1, x minus 1 cannot be 0 when you factor it. Well, if you have two things that multiply that give you not 0, they both have to be not 0. Because if one of them is 0, then the product is 0. So this means x plus 1 cannot be 0, and x minus 1 cannot be 0. So x cannot be negative 1, and x cannot be positive 1. So this time we found out there are two values that we cannot have in the domain. So let's make a number line first, before we write out what the domain would be with interval notation. So these are all the x values that make up the domain. We have two values that we want to exclude. Make sure they go in numerical order. Negative 1 comes first on the number line before 1. And now negative 1 is not included, 1 is not included, but everything else on the number line is shaded. So you shade to the right of 1, you shade to the left of negative 1, and you shade between negative 1 and 1. So notice that the number line has 3 different pieces. That means you're going to have to use union twice. This part is from negative infinity to negative 1, union. Negative 1 to 1 is between the two, union 1 to infinity. And so that's the domain written with interval notation. So negative infinity to negative 1, parentheses, negative 1 to 1, parentheses, union 1 to infinity. And so that's the domain of the original function. Okay, it's very common with these kind of problems where you have to exclude 2 to omit the 1 in the middle. Okay, but you have to make sure you include any real number between negative 1 and 1. In particular, x equals 0 is fine. If I plug in 0, I will find a y value. So this is a good place to stop. We've talked about operations on functions, addition, subtraction, multiplication, and division of functions, and also we talked about domain a lot. If you have any questions about any of the examples in this video, please let me know. Or if you have any questions while you work on the homework for this section, please let me know that as well. And I'll see you at the next video when we talk about composition of functions.